So if you have been on Instagram, TikTok or YouTube Shorts, it's possible to have come across a video or two that supposedly make fun of Newton's laws of motion or simply his scientific contributions, dubbing them as obvious and common sense. And I'm not naive to be aware of the fact that some of these videos are for comedic effect, and I'm not taking them that serious. The serious part is when people actually believe them. I've had people in my life that have had such similar criticisms of how Newton is underrated and why his scientific contributions are simply formalizations of what was known to the general public. And I do get the reason why people come up to such conclusions. For example, I hear people say comments like, of course, if you push an object, it moves. If you stop pushing it, it doesn't. Does that really need a law for us to understand? And you could be right depending on how you understood the law and the underlying concept around it. So the underlying question is, are Newton's laws that obvious? And if so, what is the genius of Newton? Provided he does not have much of substance to provide. In this video, I'll be focusing on Newton's first law of motion because I believe it's the one that is most butchered. I will get to other laws in the forthcoming videos because I intend to make a series out of this. And by the way, to fully investigate and explore the central argument of this video, I will be neglecting the fact that Bro invented calculus, early contributions to alchemy, reflecting telescope, optics and light, and so on. So to fully appreciate and conceptualize Newton's first law of motion, I will have to take you back 2000 years in the past, during the time of Aristotle. So Aristotle's view on motion and why objects move is fundamentally different from the way we would explain it today. So Aristotle believed that it was in the object's nature to stop moving as long as the causal phenomenon that led it to move in the first place was no longer in effect. Essentially, objects or bodies naturally go to rest as long as the underlying force that actually caused the body to move in the first place is no longer in effect. The body will have to naturally stop. And that sounds okay in the observational sense. And according to Aristotle, push a body, it moves. Stop pushing it, it eventually stops moving. But then, if we are to fast forward to the 1500s, we encounter a guy called Galileo Galilei. So this guy's view on motion made some fundamental changes to that of Aristotle. So according to Galileo, it was not in the body's nature to stop moving, but it's because something stopped it from moving. What he really meant here is that when a body is moving, there are certain resistive forces that will actually prevent it from continuously moving. In that way, it will have no choice but just stop moving. Meaning that if you hypothetically got rid of these resistive forces that prevented this body from moving forward, there is nothing that would stop it from continuously moving indefinitely. You notice that this is where the concept of inertia was also currently being developed. Inertia is simply the tendency for a body to resist change in motion. So, according to Galileo's view, once a body is moving, there are actually forces. There's actually this tendency for this body to resist this change in motion. So there are forces that are actually causing this inertial phenomenon or inertial sense that eventually leads the object to slow down and eventually stop. This is what leads us to the 1600s, where we meet Isaac Newton. So Newton got this concept of inertia that was developed by Galileo and his colleagues and expanded it into a well-developed framework. So for Galileo, what stops a body from moving, it's because of these resistive forces that it encounters while in motion. But Newton expanded this, stating that a body doesn't have to stop moving just because of resistive forces, but it's because of its interaction with those forces. Meaning that depending on the body's interaction with these forces, it could either stop moving, move slower, move faster, or even change direction. Let me put it this way. So as we all know, objects in the real world are always interacting with other objects in the world. For example, let me say I have this glass here. This glass is interacting with the air, molecules in space, with my hand, and the earth through gravity. So if I was to throw this glass, it will eventually land somewhere. And the reason why this glass will eventually stop, it's because we have air that is imposing air resistance onto it. We have the earth imposing gravity onto it. And if it lands on the ground, friction will also come into place. So all these objects will cause this object to slow down and eventually stop, which was what Galileo was saying. The reason as to why this glass would have stopped was because the forces it would have been interacting with were actually acting upon it in a given direction to the direction of the motion of this glass. I don't know if I'm making sense, but air resistance acts on an object in the opposite direction to the motion of this object. We have gravity that pulls this object downwards and friction that resists motion between sliding objects in contact, and so on. So if we add up all these forces together and the net force ends up being in the opposite direction to the motion of that object, the object will undergo deceleration, essentially eventually slowing down and stopping. But if the net forces end up being in the direction of the motion of the object, that object will undergo acceleration, hence moving faster. But if the net force ends up being zero, that object that was moving will continuously move at that constant speed indefinitely, unless a given force is applied on it which will change its motion. That means that it's not because of resistive forces that an object eventually stops moving, but it's because the net force of all these forces that are interacting with this object is actually zero, hence allowing this object to indefinitely move forever. And that's what Newton's first law was actually trying to say, which states that a body continues in a state of rest or uniform motion in straight line unless acted upon by an external force. The external force here is the net force of all the forces that are interacting with this body. If all these forces come up with a net force of zero, this body will continuously move indefinitely, which differs from Galileo's idea that the reason why an object stops moving, it's because of the resistive forces. But Newton says that resistive forces could still exist, but as long as the net force is actually zero, nothing prevents this body from indefinitely moving in a straight line forever and ever until the net force actually changes trajectory. This is so useful that we actually use it even today in our cars to enable them travel at a constant speed, or even in spaceships like the Voyager 1. And so you will hear people say that Newton's first law says that you push a body, it starts moving, you stop pushing it, it doesn't. But that's not even what the law says, because we have established that that's the Aristotelian view of motion, which we now know to be not true. In efforts of oversimplifying the law, we have come up to a point where people think it's obvious and common sense. But even if it were common sense, there was a time where it wasn't for over 2,000 years. And because of Isaac Newton, therefore it is. Thank you very much. See you in the next video.